Good morning, my name is Amy Luscombe, and at present my current dissertation title is Can Agrivoltaic Systems be Implemented on the Isle of Wight to Increase Renewable Energy Production? My motivation for this is that I really want to make a difference. I've been inspired by the quote by the actress and activist Gloria Reuben, who says, "A transition to clean energy is about making an investment for our future." I would love to think that my work on this dissertation could in some way contribute to this transition and help aid the future of renewable energy technology. To begin, I'll give a brief introduction into the concept of agrivoltaic systems. So, this concept is relatively new, but it's been widely discussed in the literature since 2011. So, the idea is the development of low impact solar energy techniques to reduce agricultural displacement. So, the systems can take on a number of forms. You can get vegetation centric designs that prioritise crop production but incorporate solar production. You can also get designs that prioritise solar output but grow low lying, low yielding vegetation underneath. This study will focus on the potential for mixed systems that integrate both solar and crop production, where the outcome for both is maximised. So this type of system is shown on the image on the slide, so you can see how PV panels are placed on stilts above agricultural land. The first study that assessed agrivoltaic systems of this type was set up in Montpellier in France. In an area of 820 metres squared, PV panels were mounted 4 metres above the ground and 6.4 metres apart. And then using a number of methods that will also be used in this dissertation, the productivity of land was determined. And this study actually showed that the land productivity was not reduced by incorporating two land systems into one. And in fact, these integrated energy and food systems have the potential to increase global land productivity by 35 to 73%, which is so significant. This slide will now present the research questions and objectives of this thesis. So the overall aim is to assess the potential for agrivoltaic implementation as a means to increase renewable energy production in the UK using the Isle of Wight for preliminary analysis. This will be done by addressing two specific research questions as shown on the left-hand side of the slide, which will be fulfilled by three separate research objectives. So the first question is, to what extent is the Isle of Wight suitable for solar production through large-scale solar farms? Here, this study is referring to ground-mounted solar farms rather than simply PV panels on homes. In order to do this, a GIS site suitability assessment will be conducted to assess the areas suitable for solar farms on the Isle of Wight. The second research question is it possible for agrivoltaic systems to be implemented on the Isle of Wight, and would this result in improved efficiency of land use? In order to answer this, the site suitability assessment of Objective 1 will be expanded to include agricultural land to show the potential for this agrivoltaic implementation. And the third objective will be to calculate the efficiency of such systems using the land equivalent ratio. These will be further explained in the methodology. The need for renewable energy and for the UK to have improved techniques to reach its legally binding net zero emissions by 2050 is a strong justification for this study. The IPCC has presented how anthropogenic concentrations of greenhouse gases are increasing to unprecedented levels, and it is almost certain that human influence, specifically the use of fossil fuels for energy production, has been the dominant cause of warming since the 1950s. Renewable share of electricity has increased to 40% for the UK in 2020, which is very impressive, but this has mostly been due to increased wind power and wind speeds. So as can be seen from this slide, the percentage influence of solar PV panels is actually still so small. In the first quarter of 2020, solar energy production only accounted for 1.9% of renewable energy generation, which is a tiny proportion. However, solar energy is such a large resource, and as this key statement on the slide shows, has the potential to fulfil 1,000 times the global energy requirements, but only 0.02% of this is utilised today. The problem encountered, though, is a competition between land for solar farms and the land for food production, and this is where this fairly new research into agrivoltaic systems could be very important, but is yet to be implemented in the UK. For instance, 84% of land in the UK is used for agricultural production, so if this was combined with solar PV panels, it presents a large potential for energy production. The proposed study area for this thesis is the Isle of Wight, which is England's largest island, situated in the south, as shown by the image on the slide. This image also displays how the Isle of Wight is a justified study site for assessing solar energy production, as the south of England has a much higher PV power potential than the rest of the UK, as shown by the red on the image. So a PV system in the south will generate 30% more energy than one in the Shetland Islands. Currently on the Isle of Wight, there are 4 small solar parks that have a combined voltage of 30 megawatts on average, but this is still such a small amount of the total land area. The island also has 258 kilometres squared of farmland, showing a high potential alongside the high solar radiation for agrivoltaic systems. Moving on to the methodology of this thesis, the first undertaking will be a GIS site suitability assessment. So from the literature, I have identified 6 key criteria, as you can see on the left-hand side of this table, that affect the potential for solar farm installation in the UK. So this multi-criteria analysis will be done using Boolean logic, where criteria are either given a value of 1 or 0. So criteria that meet the requirements, so for example for solar energy, a radiation of greater than 210 watt-hours per metre squared, will score a true value of 1, and that below this will score a value of 0. It's key to highlight here that for land cover, only agricultural grades 4 and 5, so very low yielding land, will be given a value of 1. These 6 raster layers will then be subtracted and overlaid to produce a map where site suitability is determined, so where all 6 layers score a value of 1. In terms of the data, most of this can be accessed through ADINA Digimap, as it requires high-resolution digital terrain models and land cover class maps, and the distance to the transmission networks will be accessed through the Open Infrastructure Map. Moving on to assessing not only photovoltaic potential, but also agrivoltaic potential, the site suitability analysis just discussed will be adapted. The land use criteria will be changed to include all agricultural grades, which will then score a Boolean value of 1. This will result in a map displaying how the potential for PV power generation is increased by also including agricultural land, and so will show the potential areas where agrivoltaic systems could be installed. However, to address a second research question fully regarding whether this would result in improved efficiency of land use, the land equivalent ratio will be used as used in the Montpellier study. So this essentially calculates whether a dual land system is more or less efficient than single land use systems in the same area. So a value of 1 from this equation here means that a mixed system is advantageous, and a value below 1 means that it will result in a reduced yield. The solar PV potential will be calculated. It's quite a simple calculation of power equals area times radiation times efficiency. So the efficiency is normally 10 to 14%, but this will be reduced by about a quarter for AV. And the crop yield is yet to be determined, but can identify exact crop yield type using the crop map of England produced by DEFRA. And then I'll delve into the literature a bit more about how to determine yield, but it's likely to use a crop model like the STIX crop model as used in the Montpellier study. So this slide just gives an overall summary of my method and how each objective will be filled. It's key to highlight that the first Boolean layer to be done will be the solar radiation using ArcGIS Solar Analyst, and this will be then combined with all the other Boolean layers. It's also key to highlight that the final part will be a validation of the results by a site feasibility assessment. This could be done in person if travel is allowed and time constraints don't hinder this. Otherwise, it will be done using Google Maps to assess the topography, built-up area in person, etc. Very briefly, I would like to point out some potential constraints that may affect my analysis. So the first of these is the issues concerning land use. So in the southwest of the island, it's a very large area of outstanding national beauty, and solar farms would not usually be granted permission on these areas. However, having researched further, a large solar farm of 10.7 hectares was granted planning permission last year on Suffolk Coast and Heath AONB, and so I've discounted this as a constraint on the premise that permission could be granted. It must also be noted that just because my analysis may provide evidence that a location is suited for solar panel placement, this dissertation will not attempt to engage with landowners to address the viability of that land actually becoming an agrivoltaic solar farm. On the method side, there is a possibility that my criteria analysis will only provide a very small area for solar farm placement. In this case, criteria requirements may have to be relaxed, or I will extend the study into the south of England. Finally, my GIS experience is currently limited, but I'm looking to spend time developing this over the summer and will take the GIS course next term. Finally, this is a simplified version of the schedule that I will present in my proposal, but it gives an idea of my steps going forward. So at this point, the most important thing is the dissertation proposal hand-in on the 29th of March, and then reviewing this feedback. And then over the summer, I plan to continually look at literature, expand my knowledge, and also use online resources such as the Coding Club to develop my GIS skills. Lastly, here are the references that were cited in this presentation and used for the images. I hope that you enjoyed this presentation into a dissertation that I'm really excited about, and now I invite you to ask questions.